maps that come about. This still forms the backbone, and it's important to know how to do one of these in order to be a competent process analyst. The topics we're going to cover today are some basic background concepts and context. We'll talk about the definition uses of the mapping types and mapping conventions, and we'll show you how to construct a linear process map. So first we want to talk a little bit about the context that process operates in for any business or organization. We believe that performance in an organization has three main components, and the first one, of course, most obvious to most people, is the organization level, how the organization is put together. So collections of people, often grouped together because of competencies or other organizing principles like location or product line. This is the most visible part of most organizations. This is how the money is usually allocated and managed. The issue is that the component of the organization that actually delivers value to the marketplace is the process level, and this is the level we're going to talk about today. It includes workflow, information flow, materials flow, and even the layout of equipment and space. And we'll talk a bit about all of those and what the differences are and what the linear map is actually depicting. And finally, of course, there's the performer level or people level. And ultimately, when you make a change to process organization, you're impacting that person. And so it's one thing to be able to model a process or design a new process, but of course, at the end of the day, we're also going to have to understand how people are impacted by that. So, what is a process? For us, at least from a structural standpoint, a process has some very basic components. If you look at any process, the first thing you need to understand is what is the output? What is that thing of value that's being created for some recipient or customer of that process? Then you have to understand on the boundary at the front, or the right-hand side, what's the trigger? And for us, the trigger is extremely important in process mapping because it's the event that initiates the work. And so it's one of the things that helps you separate one process from another, is understanding what the different triggers are. And finally, of course, there are also suppliers and inputs. So this is the familiar SIPOC model of process with the trigger added. Now I want to emphasize, though we're going to be talking about process mapping today, that the model is not the process. Process is the actual living, breathing transactions occurring in your organization. Every time a process is triggered, there's a transaction, and over time you can observe those transactions. That's process. It happens. It's how work happens on a day-to-day basis, on a minute-to-minute basis, depending on the volume of the work. And so when you're managing process or designing process, what you're really trying to do is impact how that work occurs by building these models. But the models aren't the process. They're just a depiction that helps you reorganize the work. Now this slide is both very important and also a little bit elusive. We like to think of process in different levels of detail. People often ask us, I don't feel I'm mapping my process at the right level of detail or at a consistent level of detail. So here are some guidelines to go by, but they are more art than science. We start at the top level, which is process. Now, how do I know I've got a process? My guidance on that is that your output has value and is consumed by some user. So process by its nature has products that are being used by someone. So if the product is not a final output that someone is using, say you have a payroll process that goes to an internal customer, it's providing a paycheck, or you have an order fulfillment process that provides a filled order to an external customer. That's what I'm talking about for process. That's the top layer. Beneath that, we like to break these down into sub-processes. Again, this is a very high-level depiction of a process that shows the value-added events inside the process at the highest level. You can almost think of these as milestones. So in our example, we have a developer support process. Essentially, the mission of this process is to assign someone to work on a support request. And you can see the sub-processes there. And then finally, step level, which is traditionally what we're mapping. This is the what, or the workflow level. This is what happens in sequence. So you begin to see sequence of events. And also, this is the level where you begin to see feedback loops and decisions. So you see the diamond symbol in there. This is where most people are operating when they're doing process design work. The final level, or the weeds, is the task level. And this is the level of how things are done. So how an individual step is executed by a person. And this is rarely something that we would start mapping for process analysis. If you're down at the level of how people do things, if you're really doing a process improvement project for a big end-to-end process, you've gone too far. How do I know I'm at the task level? Typically, the task level is something that a series of events that one person executes in a very short amount of time. It can be very important to process improvement efforts. If you change the methods that someone does something, for instance, you can automate how they take an order. It could be on paper in your current state, and you might want to speed up the transmission of that by putting it into a computer. But still, overall, if you're analyzing workflow, looking at the task level, the how level, is probably too far down the weeds. And these levels become important as we explore the different types of maps. So if we're in a process improvement project or a process redesign project, the idea is that you start with some sort of performance issue with the process, what we call critical process issue, and some goals for the process. Usually there are critical dimensions such as volume, time, cost, and quality, or a combination of those that are at issue. Then you do a cross-functional process map. And this is very important in what we call discovery, when you're trying to see what the current state is, to see where the handoffs are. So when you're doing current state is map, you would want to use a cross-functional map because the handoffs are a great source of improvement opportunities, and you want to document those. That may be one of the things you change. Then you would look at what your requirements are for that process for your future state, potentially brainstorm some concepts, what we call the could be. And now we get to the subject for today. You're going to take a look at linear process maps. These are maps without the context of who. They don't show who does what. They're really the essence of the process. We're going to be looking at what happens and in what order so that we can make changes to the sequence of steps, the number of steps, whether they're in parallel or not, to make improvements to the overall process flow. We want to do this without the context of who does what so that we keep those turf issues from interfering across functional map for the future. Some definitions. A linear process map is the work steps and flow to convert sub-process inputs into outputs. So basically, each sub-process in a map would have its own linear map. It's great for developing new business processes. I would say its primary use is in helping you design a new process. It could be used for discovery, that is to document an existing process, but we find that we use it most for designing new processes because it shows the essence of that workflow. It helps minimize turf issues because it concentrates on the optimal way to create those value-added sub-process outputs. And it's definitely a key precursor to your cross-functional map that you'll use eventually to deploy the new process to the organization. So it's, to me, the linear map is the first step to any sort of more detailed analysis of a process. If you can do a good linear map, then you can do many of the other types of maps I'm going to discuss in a moment. The tools you need for a linear map, if you're doing it with a group, typically it's our good old Post-it notes, large sheets of paper, and some Sharpies. Any number of software products allow you to make these type of maps, but we feel that when you're working with a group to design a process, it's best to start with the paper. It really gets them something about touching the Post-its and building the map themselves, really involves them in the activity, gives them really a different level of understanding of the process and the flow. Now, here are some different types of map and how they are used and how we might use them with the Rumble Embrace methodology. If you look at the top, we have a process relationship map, which we'll cover in another web seminar. This is how we show the relationship at the process level of an organization's process. It could be the entire organization, could be a business unit. It's very important for scoping and understanding where the priorities are at the highest level. Process profile, also called a sub-process map, is a fundamental tool for scoping process and is used as an input into the linear map. The linear map, which we cover today, depicts the essence of the workflow. It's primarily used for process design. So the linear map, and I have it highlighted, is really the backbone for all these other maps I'm going to discuss that you may encounter in your analysis. A cross-functional map, which we've talked about before, is a linear map with the context of who does what. So it shows organizational handoffs, it shows interaction with systems, so the flow of information, and you can also show disconnects, especially if you're doing a current state map. Value stream map, which is often used for streamlining or lean projects, is similar, but it's got some different notation, and it really shows the flow of information materials with a special emphasis on cycle time. It's very helpful also, in addition to discovery and design, it's very helpful for scoping large process improvement opportunities on a very large process, say an entire supply chain, because it will show you where the cycle time opportunities are from end to end. Spaghetti diagram is a little bit different. It actually shows the flow of work product through physical space. So it's not showing work steps as much as it's showing stops along the way, locations. I do this work in the lab, then I do this work in the warehouse, and then I do this work on the shipping dock. And so it's really used to see the pathways that the work product flows through the organization to look for spatial improvement opportunities. So it's kind of the oddball in this list. And finally, you have what's called Business Process Management Notation, or BPMN. You may have heard a lot about this lately. It's essentially no different than your basic flowchart, your basic linear map, except that some new symbol sets have been added to depict certain types of process objects. So the trigger that I talked about gets classified any number of types of trigger. Recurring loops and rework loops are depicted in a certain way. Gates are depicted in a certain way. So it's really for modeling process, very effective for high transaction processes, information-intensive processes. And I would say, although the notation has been developed for 20 years, it's still pretty much in its infancy. And if you have an organization that has never mapped its processes using a linear map, it's going to be very difficult for them to understand how to put together a BPM map. So the linear map, making a good linear map is often the best first step to creating any of the rest of these. Let's take a look at the symbols we used. These should be familiar to most of you. The terminals, which would be the start and the end of the process, show either the trigger or the end of the process. You can put start in the initiating terminal, or you can even put the event that actually triggers the process. The steps are the boxes, and at Rummler-Brache we have a peculiar habit of trying to limit it to a noun and a verb. We don't want to get too many words in our process boxes, and we like to say past tense verb with a noun, as you see in this example, order entered. And the idea is that the process is showing a flow, and so when I leave the process box, when I get to the right hand of that box, the event or the work has already happened. So I'm really sort of showing what has happened rather than giving instructions, which would be more like a procedure. And that's why we do that. Connectors, arrows, and of course decisions. Now decisions are something that are very important to understanding the behavior and performance of a linear process map. And I'll go over types of decisions in just a moment. Here's an example. It doesn't have the terminals on it, but this is your basic flowchart that you've seen before. I want to talk a little bit, though, about mapping decisions, because this is something that gets to be important when you're mapping a linear process map at the step level. We believe there are three basic types of decision structure you see when you're mapping. The first is what we call a do-over, which is where you have some event. Let's say you've entered an order, someone reviews the order, and then they examine it to see if it's complete. If it's not complete, they go backwards and go through those same two steps again in this example. The reason this is important is you can use the linear map for performance analysis if you have estimated the cycle time or labor cost of each step, and you know the percentages for the decision, how many times yes, how many times no. You can predict the performance of the process. How much rework do I have, basically? So this could be called the rework decision. We see this a lot of times at inspection steps. Something is inspected, it either passes or fails. Probably the most common decision structure we see in processes. Another one is where what we call the do more, where you get in a process and you're deciding, do I have a product of type A or type B, or a transaction of type A or type B? And for instance, maybe I'm developing a proposal, and if the proposal comes from the government, I have extra sections I have to add to that proposal. And so if the answer is yes, I would have to do more work in order to get to back into the process flow. So you see in this example, if the answer is yes for whatever the question is, you do more work and then you go back into the main flow of the process. Again, if I know the percentages there, I know how much extra work I have to do, and I can estimate the labor cost or cycle time associated with that. And finally, we have the do different, and this is where you have situations where the process splits into two or more paths downstream, and is essentially different processes. And so this is often the case with tech support, for instance. You may have tiers of support. Once you've reached that decision point and you decide which tier it is, you've got different essential work steps, different people performing them, etc. And so now you're doing things differently. Each of those paths has its own cost, its own cycle time. And so understanding the role of decisions in a process is critical to understanding the performance, especially when you're doing the design. Now, how do we construct one of these maps? Basically, we want to begin with the process we want to design. So it's important to have everyone in agreement at the very highest level, that process level. What are the value-added outputs? What are the triggers and inputs that come into the process? Then we want to model what we believe the sub-processes to be. This is important. I would never just jump in and start saying, step one, tell me what step one is, tell me what step two is. That's not the best way to go about this. What you want to do is have this high-level context first. And so you want the 4 to 6 major chunks of work. These should provide something of value that gets you closer to that end output. And you'll see an example in a moment. And then what we like to do is talk about the inputs and outputs for each sub-process, and maybe even some of the requirements. Depends on the complexity of the scope and what you're trying to achieve. Once you've done that, once you have that context, so everyone's clear on what the inputs and outputs are, they know what the sub-processes are, then you can map each sub-process as a linear map and then connect them all together. So again, using these post-its is a very straightforward activity. I find teams can do this fairly easily, especially if you give them an example. So here's the example. Start with something everybody knows, customer cravings. Pizza order fulfillment process. And so you've got a trigger of say a customer craving, or probably more realistically a phone call, and then you have a delivered pizza at the end. What you would want to do is decide what the sub-processes were. So in this example, the team has decided, well, we take the order, we then assemble the pizza or make it, we bake it, we put it in a box and add some stuff to that, and then we deliver it to the customer. And so now that they've agreed on that, developing the linear map is very straightforward. They would start with the first piece and talk about what are the essential things that happen to create the completed order ticket, for example. And this example, they answer the phone, they record the information, they read it back to the customer, confirm it, and then add it to the work queue so it passes on to the next sub-process. You see that they do have one decision in here, and it's important. It's important to confirm that order. It probably prevents rework down the line. But also, over time, they can analyze how often they have to redo that order and diagnose something with their process that's not working well. We go on to the make it. So that order is reviewed. They toss the crust. They sauce the crust. They add toppings, and now they have a pizza ready for the oven. The assembled pizza placed in the oven, baked. remove to the boxing area. Now, one thing you could do to analyze this as you're building your design is you could put cycle times and or labor cost, if you could get them, onto each of these boxes. For instance, it may be a constraint that pizza baked may take 12 minutes. It may be a non-negotiable that once it's in the oven, it takes 12 minutes. You could assign 12 minutes to that baked and then figure out if that's a constraint, what are some things I can do in the other steps, either preceding or following, to save some time. So a linear map is a very easy structure to layer additional information on. Box it. They fold the box. They put the pizza in, attach the coupons, the menu, and the ticket, and then move it to the pickup window. And then finally the pizza gets delivered and the payment collected. So again, going through an example like this with the team will help them do a better job laying out their own process. And what I want to emphasize is this idea, this top-down approach, we feel really puts people in the right frame of mind to not jump down in the weeds. They're not, for instance, if we go back to the assembly of the pizza, they're not talking about how they put the sauce on the crust. Oh, I put 2 ladles and I move them counterclockwise around the crust. That may be very important from a procedural standpoint, but that's later. We're looking big picture. What can we do here to improve this workflow? What can we do to either combine steps, remove steps, or resequence them in some way to get a better process? So, in summary, linear process maps are really the most fundamental type of process map. They form the backbone for all the other types of map. When we're using a linear process map, we always want to start at that sub-process level and identify requirements before we begin mapping things out. So we recommend that you always get that context before you dive down into the details. And finally, they only depict workflow. They concentrate on what of the process, not the who or how. So they're a precursor to more detailed information. If I was to complete my process design project, I might have to construct a cross-functional map because now I want to know who does what. And now that I've got that backbone, I can simply look at the competencies required, think about the location of people, and start to make those decisions. I've already got my process map. I'm simply placing them in the correct function. If I want to talk about how things happen, then I can create more detailed maps for a single step, what we would call maybe a procedure at the task level to improve specific steps that were problematic in the current state. Maybe the baking was taking too long and they wanted to explore technologies, maybe ovens that baked things faster, or maybe they wanted to increase their capacity so they had fewer pizzas waiting in backlog to go into the oven. Those things would be next steps. Then you may even use a different type of map. You would start with your new linear map and then build a new cross-functional map or value stream map or some other type of map to give you more detail. But we always want to start with this bare bones basic process map to make sure that everyone understands the essence of that process before we get too far into the details. So that's it for my presentation on linear maps. Very, very straightforward. I hope you attend future presentations on the other types of map that build on this. And I've been very happy to speak with you today. John, I'm going to turn it over to you.
Great. Thank you very much. It's been kind of exciting in Dallas today with an ice storm, but we were able to continue with the webinar this morning. Thank you. Dave, thanks a lot. You can tell a lot of experience has gone into putting these maps together. So if any of our participants have questions this morning, please direct them to me and we'll be sure to handle them individually and get back to you. Again, thank you for joining us, and we appreciate the opportunity to get together with you on this webinar. See you next week.